Hello friends, I Professor Shubhangi Inge from TSSM Bhuravai Savan College of Engineering and Research, Nare Pune, Department of Computer Engineering, Laboratory Practice 1. In today's sessions, I am going to explain that assignment number 3 title is Implement a Classification Algorithm, that is a Recursive Partitioning and Regression tree. Now I read the problem statement of this assignment. Trip history analysis. We use a trip history datasets, that is the form of bike sharing services in the United States. The data is provided quarter-wise from 2010 quarter onwards. Each file has 7 columns. Predict the class of the user. Sample the test data available from this site. Now the learning objective. To learn how to split the data into the training and the test datasets. To learn the condition probability of each features in the training datasets. To learn how to display the predicted and actual values. Outcome. Student will able to understand how to split the data according to the split ratio. Student will able to understand the summary of every node in the constructed decision tree. Student will able to understand how to generate the prediction. Now our first operation is split the data into training and test data. First we have to understand what is a train data and what is a test data. Train data sets is a subset to train the model. Test data is a subset to test the train model. We require dividing the data into the train data sets that can utilize to predict the prediction and test the data sets. We require to divide the data sets randomly into the train and test data with the ratio. Now here we are considering the ratio is equal to the 0.9, so we can consider the 90% of data will be the train data sets and 10% of the data will be the test data sets. Now moving to the next part for the recursive partitioning and regression tree. Some points is given here. Statistical method for multivariable analysis. The recursive partitioning is a statistical method for the multivariable analysis. Multivariable analysis is a subdivision of the statistics encompassing the simultaneous observation and analysis for the more than one outcome variable. Now, recursive partitioning creates a decision tree that strives to the correctly classify members of the population by splitting it into the subpopulation based on the several independent variables. Here is the decision tree. We are using the decision tree concept. Is one of the predictive modeling approach used in the statistics, data mining and machine learning. The process is termed as a recursive because each subpopulation may in turns to be a split an indefinite numbers of time until the splitting process terminates after a particular stopping criteria is reached. Now with the help of this formula, with the help of this code, we get the R part. So fit R part, train members type, data is equal to the train, method is equal to the class. Now moving to the R part. Here in that R part we are having the formula. The data specifies the data frame containing those attributes mentioned in the formula, and in the method we are defining the class. For classification tree we are having the class and ANOVA for the regression tree. Now we are having the plot fit. After completion of this we get the plot fit. Here plot the decision tree. So it will be give the output of this decision tree. Then next is the text fit. Text fit label the decision tree plot. So it gives the labeling for the decision tree. Now moving to the next is display the predicted and actual value. Now with the help of this code, predict fit new data is equal to the test minus 4 type is equal to the class. What does this line indicate? Here predict is nothing but the prediction from the fitted R part object. So here we are using the object is nothing but the fit. So what did it say? Fitted models of the objects of the class R part. This is assumed to be a result of some function that produce an object with the name components as returned by the R part function. Then we are having the new data. New data is equal to the test minus 4. New data, now let us see with the what is the new data. New data is a data frame containing the value at which predictions are required. The predictors refer to in the right side of the formula object must be the presented by the name in the new data. If missing, the fitted values are returned. And here is we are having the test minus 4 that test the data excluding the last column. Now the next term is we are having the type. Type is nothing but the character string denoting the type of the predicted values returned. If the R part object is a classification tree, then the default is a return prediction, a matrix whose columns are probability of the first and second class. Now we are having the mean. Mean predict is equal to test member dot type. So it gives the means of the true prediction. Next is the output C bind test prediction. This display the output of the test data. Now after completion of the theory part, now moving to the practical executions of this assignment. My data capital bike share. Subset underscore my data C 1 4 6 9 temp faint subset no subset is not sample dot split subset of my data underscore my data split ratio that is equal to 19 is equal to the 0.9 train subset underscore my data temp underscore field is equal to the true. Same for the test. Subset underscore my data temp field is equal to false. Summary train summary train summary test head train head test. In this executions we are having the splitting ratio. For the splitting ratio we are assigning the ratio is 0.9, that is 90% of the data will be a train data and 10% data will be the test data. So we will get the train data and test data. In that, after that we are having the head train and head test. In that we are having the first 5 or 6 entry of the CSV file, and a head test is nothing but it gives the last entry of the CSV file. Fit R part train member dot type data, that is equal to the train method, that is equal to the class. As I already explained in the slide, what is the R part, what are the train members, type, data, train, methods and the class. Now I again repeat the same part, that is the here is the R part, we are using the recursive functions. Data is nothing but specifies the data frames containing those attributes mentioned in the formula. Here we are using the method is for the class for the classification tree, and if there is a ANOVA is present, then it is for the regression tree. Now we are moving to the plot and text. Plot fit and text fit. So plot flicks plot the decision tree and text flits label the decision tree plot. Now moving to the next, predict. Fit new data, that is equal to the test -4 comma type is equal to class. Now we are moving to the mean. Spread is equal to the test hyphen member dot type. Output C bind test and predict. View output. Now this line predict fit new data test -4 type data. Here we are having the predict function, predictions from the fitted RPAT objects. Here we are using the object is nothing but the fit that fitted the model objects of the class of the RPAT. New data is the data frame containing the value at which predictions are required, and type test is equal to the -4 test data excluding the last columns. And here we are having the type character string denoting the type of the predicted value to be a return. Here we are using the classification method, that's why we are using the class as a method. So execution part is completed. I'll save this or this thing.